Hi everyone, hope you're doing well. This is a video to go over do now number 12 for our Regents review. Please make sure you post all these pages for me on Google Classroom so you get credit for today's classwork. So today's just a couple of little random things, and the majority of it is going to be our stats stuff. So, all right, here we go. Number one, a taxi ride costs $2.50 for the first mile and 75 cents for each additional half mile. So that's important that you notice that says half mile. Okay, if X represents the number of additional miles, so note now this is full miles, which function accurately represents the cost of a ride in this taxi? So first mile, this is usually your y-intercept. So that's going to be like your B. Anything that keeps happening over and over consistently, that's going to be your M. So that's really not horrible. The only tricky part is this right here. X, what you would normally, right, multiply the slope by is the number with the X, is additional miles. But this is a half mile, okay? So how many half miles make one full mile? So a half and a half equals a whole. So 2 half miles equals 1 full mile, okay? So that's going to come into play. So we have to really essentially take the 0.75 and multiply it by 2 of our additional miles, okay? So multiply it by, let me show it this way a little bit, make a little more sense. Multiply it by 2, okay? So now what the questions show is they don't really show the 75 cents being multiplied by 2. They have it shown it being multiplied by the X, but that's okay. Remember, all of this is being multiplied, right? Everything's multiplied. So it doesn't matter where you put the parentheses because the associative property allows you to move it around. So the answer is A, okay? So a little note right here, since 75 cents is the cost for half an additional mile, we do 0.75 times 2, right? But in this case, we're multiplying it also by the X to get the cost of each, so meaning 1 mile. All right, so again, you have to double this amount. You have to double the 2, but they just show it a little bit differently. Instead of having the parentheses here, they move it here. Again, we can do that. We can swap them because of the associative property of equality. So it is choice A. All right, number 2 is going to be a graphing one, so you'll need your graphing calculator for this. So this was going to be assistance, but a little bit different than what you're used to. You're going to have one that looks like this, and if you notice, that's going to be your exponential, and then our next one looks like this, and that's going to be your linear. So we have exponential and then linear. So after we graph them, we're going to have to state the coordinates of a point that satisfies the equation. And remember, that point that satisfies is called your solution point. And that's also going to be your point of intersection. Point of intersection. Okay, good. And this right here basically is just saying, you know, f of x, which is your exponential, and g of x, that they're equal to each other. So that, again, is just letting you know that you're looking for the point where they're equal to each other. Okay, so let's split it up. So we have our exponential, and then we're going to have our linear. So we'll do our exponential over here and our linear over here. So for exponential, we're going to go to the calculator. And we're going to just look up the table. Remember, any number in front that's bigger than 1. This is not only your y-intercept, but this is also going to tell us that the graph is going to be narrow. Remember, anything bigger than 1 was narrower. And this number, again, is the y-intercept, so where it begins. And then this exponent, this base right here, the 1/2, that's going to show exponential decay. And that means the numbers will be halved. Okay, so you're going to notice that when I go to do this table right here and we got these numbers, that they're going to be halved. All right, to the calculator. So y equals 4 times 1/2 to the x. I'm going to go to the table, and I can only go up to, well, that's way too high, -2.6. Okay, so -1, 0, 0, 4. I'm only going to go to a couple of decimals. That's about as much as I'm going to go because, like you guys know, I'm not crazy with the decimals. So -1.8, 0, 4. Look, there's that y-intercept, right? That's what we said it was going to be. That's going to be your y-intercept. Then we have 1, 2, 2, 1, 3.5, 4.25, That's 0.5, 0.25, and then 5.125. Remember, this is going to get closer and closer and closer to the 0, but it's never going to go into quadrant 4. Okay, that's what you learned. Okay, so -1.804, that's our y-intercept. Again, we knew it from right there, y-intercept. 1, 2, 2, 1, 3.5, 0.25. Okay, so we're going to use arrows because no constraints given. So we're going to have our arrows coming up this way, and then we're going to curve our exponential function and go closer, go closer and closer and closer to 0, but don't actually ever cross it. So f of x equals 4 times 1/2 x. I'm just going to write that. So does not go into quadrant 4, and that's because basically it's never equaling 0. Okay, that's our basic if it's not moved down. All right, so that's your exponential. Not horrible. If you notice again, look, those numbers are all halved, like we said from up here they would. All right, linear. So we have g of x equals 2x minus 3. The easiest is the slope and the y-intercept way. You could do the table. I'm not going to do that. So you're going to begin at -3. And we're going to go up 2 to the right 1. So up 2, right 1, up 2, right 1. There we go. There's our intersection point, up 2, right 1. Follow that pattern down to left 1. All right, nice straight edge. And don't forget to label it. G of x equals 2x minus 3. Okay, there was your other one. And there is our solution point right here. Solution point looks like it's 2, 1. So 2, 1 is the point of intersection. That's the coordinate that satisfies both of them. You could plug it back in to figure it out. You can actually even just do it this way. If you put the second equation in, 2x minus 3, and you go to the table, we again said that 2, 1 was the answer. So look, the y1 and the y2 both have 2, 1. You know when you see repeating y values that is the answer. So that's the quicker way to figure it out. All right, page 1 done. So now we're going to go to a bunch of stat stuff. So you should hopefully remember all this. So number 3, which set of data describes situation that can be classified as qualitative or categorical? So remember, qualitative, that was no numbers. That's when we were talking about a description. And most importantly, cannot be measured. Okay, cannot be measured. That's the best way to kind of figure it out. So the colors of the birds at the city zoo, the shoe size of the zookeepers, the heights of the giraffes, weights. So it's kind of like which one's not like the other, basically. And that is 1. Colors cannot be measured. All right, number 4, bivariates. Bi meaning 2. Okay, so that's 2 variables, and you're always going to see a comparison. Okay, if I could just remind you, univariate, that's when you see frequency. If you see the frequency in the chart, that's how you know. Let me write this again so you can actually read it. Univariate. Okay, that's how you know it is. Univariate is when it says frequency. So we're looking for bivariate. So 2 things that are being compared, 2 different units. Okay, age of students in the club, that's just 1, it's just the age. No, grade level and age, there you go, 1, 2, that is our answer. Type of lunch, that's just 1. Attendance, just 1, so the answer is 2. All right, number 5, Erica is conducting a survey about the proposed increase in the sports budget in the hometown school district. Which survey would be most likely? Okay, most biased. So most, remember, bias means not fair. So we want most unfair, which means that there's probably a couple that are not fair. We want the one that's most not fair, okay? Erica asked every 3rd person entering. Okay, so what's the survey about? So survey is about the sports budget, okay? So keep that in mind. So we want most unfair. Every 3rd person entering the grocery. No, that's pretty fair. That's pretty good. 3rd person leaving the hometown shopping mall this weekend. 5th person entering the hometown high school. 5th person leaving Saturday's home. Oh, well, there you go. Because it has to do with sports, you're going to look for the one that says sports. So that one's definitely the one that is most biased, most unfair. All right, number 6, a scatter plot shows that a person's weight, as a person's weight increase, their scores on a math. So this one increases, their score on a math test also increases. So kind of already think about what that's going to look like. You have the weights, and then you have the score, okay, and as one increases, the other increases. So which of the following best describes the relationship? So negative, so definitely the negatives are out, okay, so it's positive. So causal or not causal, okay, so remember, the plain old correlation, that just means the relationship. One thing has to do with the other, okay? But then causation, well, that's a whole different thing. Causation means one thing 100% causes the other, okay? I always give the example that we have a blizzard, we have like 6 feet of snow, that's going to cause us to not go to school. We know what caused the action, okay? So as a person's weight increase, their score on the math test. So just because you become a little bit bigger, does that mean that your math test score is going to increase? No, that's just the silliest thing I've ever heard. Okay. Moving on. Number 7, which data set describes situation that could be classified as quantitative? Okay, so now quantitative, that is your numerical. And obviously numerical has to do with numbers, but really most important is that it can be measured, okay? And this is an awesome question. This was given on a Regents, and it stumped a lot of kids because you're going to notice that all of these are numbers. Phone numbers in a telephone book. The addresses, those are numbers for students. Zip codes, those are numbers. The time, everything here is a number. So this whole numbers, not numbers, is out the window. You have to have the deeper understanding of it can be measured. What's the only thing, which is the only number that can be measured? Time. Time is the only thing from this list that can be measured. That was a tough one. Okay, last page, number 8. For the following graph, describe the distribution as symmetrical, skewed, uniform, or U-shaped, and then state whether you're going to use the mean, median, or neither to represent a typical value. Okay, so symmetrical, I guess I'll just kind of show the examples up here. Symmetrical is basically when the two halves mirror each other. Okay, see how like this side could fold over to this side. Skewed, well, that's actually what we have right here. This one is going to be skewed to the right. And the reason it's going to be to the right, because this is where the direction of the tail is, okay? If it was skewed, let's say, skewed left, okay, let me do the picture first. That would start with like the smaller ones here, and then it gradually get to the bigger ones over here. So this is skewed to the left, okay? Uniform was like that straight across, and then U-shaped is kind of like opposite from the symmetrical almost. It looks like this. Like that. This is the most typical one. Also, you have your bell curve. We called it that. All right, so we talked about this being skewed to the right. Again, direction of the tail is where it's skewed. What's causing it to be skewed is an outlier, okay? So think of, you have all grades in the 90s and 100s. You get one bad test grade, like a 30, and it's going to pull down your average. So it's pulling these grades this way. So because it's an outlier, that's when we want to use the median. So median, because an outlier is causing it to be skewed. So if there was no outlier, we would use the mean, but when there is an outlier, like in this case, we would use the median. All right, number 9, the table below shows the number of prom tickets sold over a 10-period day. Write the linear regression equation, round to the nearest hundredth, and then usually, part B, correlation coefficient, nearest 10,000, explain the meaning. I'm going to add a little bit on here in the context of the question, because you know how you've been doing these Regents and you've been seeing more and more that they've been asking all about the context. So I want to make sure we practice that. All right, so these are your L1s, these are your L2s. You're going to put the numbers into L1, L2. So just remind you, put numbers into L1, L2. To do that, you're going to press stat, and then we're going to press number 1, and we're going to press edit. All right, so take out that calculator, stat 1. Go ahead and clear out everything that you have in there. And let's get to work. 1, 2, 5, 7, 10. 1, 2, 5, 7, and 10. 30, 35, 55, 60, and 70. All right, then you go to stat, move over to calc, and go to number 4. Now we're going to 4 because it says linear regression, linear regression. Okay, before I press that, let me write that down. So we said stat. We said move over to calc. Okay, then we said number 4, linear regression, and it does all the work for us, and we're going to get our equation. So we have y equals 4.5 10 hundredths, the 7 rounds us up to a 4, And then 27.10 hundredths, the 4 keeps it the same, 31. Okay, while we're on this screen, we already have our R, so R equals 0.9. We want 10 thousandths, tens, hundreds, thousands, 10,000. So the 5 rounds us up to a 2, 0.9832. Let me also show you while we're here how to turn it on. If you don't have it, easiest way, mode, scroll down until you get to stack diagnostics, and then make sure it is turned on. Okay, so we'll just go back to the screen so you can see the information. And there's all the numbers. All right, so let's write this down. So to turn on the R, what you want to do is you want to press the mode, then you want to press down, and you're going to go until you see it says stat diagnostics, and then you want to turn that on. Okay, so our number was 0.9832. So the correlation coefficient is always the R that it's looking for. Okay, and now you know the sentence. The correlation coefficient shows a strong positive because it's a positive number, strong because it's close to +1, linear relationship, linear because it does say linear. If it doesn't say linear, then don't say it. So correlation coefficient shows a strong positive linear relationship because the correlation coefficient is close to +1. Now remember, in the context means you want to describe positive slope, positive relationship. Okay, basically that's your X and your Y, that's your day, and that's your number of tickets. And as one increases, the other increases. That's what you want to do. But you want to make sure you have to use these words. Make sure you're using these words because it says context. Don't make up your own. Okay, so here we go. So this means as the number of, all right, so what's the first one? Days. Okay, so number of days increase or increases. The number of, all right, what's the second one? Number of prom tickets sold. Again, don't make up your own words, use those. Also increases. And that's it. That's not horrible. You guys could totally do that. All right, the last little bit is just a little bit of highlighting. It's just basically going over what we just learned and what we talked about today. So the best measure of tendency. We talked about when there is no outlier, that's when you use your mean. When there is an outlier, you use the median. And the mode is used something like an opinion, like what's your favorite class, what's your favorite ice cream, what's your favorite book, things like that. Best measure of spread. So this wasn't really talked about too much, but if you have skewed data, you want to use the range. If the data is close together, you use the interquartile range. Bias we talked about was not fair. Unbiased is fair. Quantitative can be measured. Qualitative cannot be measured. And then the only other thing I wanted to write, just so you had it here on your paper, your outlier formulas. And formulas for the lower boundary and then the upper boundary. It's D-A-R-Y. Okay, so it's Q1 minus 1.5 times IQR, and then Q3 plus 1.5 times IQR. All right, so hopefully that was not bad. Hopefully you guys are okay with do now number 12. If you have any questions at all, please let me know. If not, please make sure you post these so you get credit for them. And yeah, that's it. Hopefully you have a great day. Take care.